Hi guys, I've received a couple of questions about these problems from Unit 1 review. So to solve these inequalities, you just pretend like it's equal and isolate the term that contains the variable, move that 4 to the other side. When you subtract, you don't have to flip-flop the sign. So far, so good. Then you got to divide both sides by -3. When you divide or multiply by a negative number, you got to flip-flop the sign. So this becomes x, and that sign switches, goes the opposite direction, changes from greater than or equal to less than or equal to, and then -5. So here's the solution written in set builder notation. The graph of this solution on a number line, highlight the -5. As long as your variable is to the left of your inequality, then this tells you the direction that your arrow tip goes. The or equal to bar means we're going to plot a solid dot on -5. And we shade everything to the left. Or you can test points like -10. -10's down here. It should be included in the shading if it makes this true. Is -10 less than or equal to -5? You could test a point over here like 0. 0 is not included in the shading, so 0 should not make this true. Is 0 less than or equal to -5? And the answer to that question is no. So this is the picture of the graph. Now, rewrite this set builder notation into interval notation. Interval notation has to be in numerical order. What's the smallest x value that will make this statement true? That's -infinity. Remember, you can never quite get to positive or negative infinities, so we're going to parenthesize those. It means we can't quite get there. We're just approaching it. What's the biggest number in our solution set? And that's that -5. -5 is the biggest number. Now, if it was just strictly less than without this bar, we would parenthesize it. But since the bar is there and we can include -5, we use brackets to show that we can include -5. Let's take a look at another sample just like it. Pretend that it's equal. Add 3 to both sides. Divide both sides by 4. This time dividing by a positive, we don't have to flip-flop the sign. When we put this on a one-dimensional number line, we put the root 13/4 over here. The arrow, as long as the variable is on the left-hand side, will be the same direction as our arrow here. Or you can test a point. The absence of the or equal to bar means it's hollow, and we shade it to the left. In other words, if I put in a point that's in the shading like 0, is 0 less than 13/4? Yes. Every number in this shading is less than 13/4. On your My Open Math, it will have this shaded part right on the number line itself. Okay, so don't let that screw you up. Now we have to change this, which is set builder notation, into interval notation and make our answer look similar to this. We use the smaller numbers first. In this case, -infinity is the smallest number that will make this work, the smallest number that's in the shading. We never include infinities. We go all the way up to the biggest number that is included in our shading is 13/4. But since it's hollow, we can't quite get to 13/4, so we need to parenthesize that. Make sure in this interval notation that these guys are in numerical order, small first and then followed by big. I hope that helps. We'll talk to you soon.